Today we're going to take a look at identifying zeros, or the x-intercepts of parabolas. And so we want to be able to do that both from graphs as well as equations. But in order to start warming up, I just want to go over a couple of things. We'll look at some expanding and some factoring, some converting from vertex into standard form, because those are going to be useful skills as we're moving forward in this next section of the course. So we'll start off by expanding out the example that's here on the left-hand side. And so here we have 3x times x minus 5. And so if we're going to expand this, that means we're going to use our distributive property. We're going to multiply 3x times x, and we're also going to multiply 3x times negative 5. So if we do 3x times x, we end up getting 3x squared, okay, because x times x is x squared. And 3 times the coefficient of 1, which is in front of the x, is just 1, so 3 times 1 is 3. And then second thing we need to do is 3x times negative 5. So 3 times negative 5 gives us a 15, and the variable x times 1, because there is no variable x over there, gives us just x. So we've now expanded it. The next thing that we want to take a look at is, again, we want to recall how to do a conversion from standard form or from vertex form into standard form. So what we have here on the right-hand side, this is an example of vertex form of a particular equation, or rather of a particular parabola. So we want to convert this into standard form. So the important thing for us to remember is that there is a binomial in the middle, and we can multiply those two things together. So our binomial is actually right here. It's the x minus 2 all squared. And so because it's squared, it means x minus 2 times x minus 2. So the first thing we need to do is actually rewrite this. So we end up with y is equal to 5 times x minus 2 times x minus 2, and then fill out the other bracket, plus 9 on the end, because we still need to keep that 9. We will deal with it eventually. So the next thing that we have to do is go through and actually use our distributive property and our FOIL pattern and multiply these two x minus 2 binomials together. So that's going to leave us with y is equal to 5 times x squared minus 2x minus 2x plus 4. Okay, and again, we got the plus 9 on the end. So now what I can do is I can consolidate, or I can use collect all of my like terms. So I'm going to do that. I'm going to have 5 times x squared minus 4x, because negative 2x plus negative 2x gives us negative 4x. Again, plus 4. And then we have the plus 9 on the end. So now I have 5 times everything in the bracket, so I'm going to use my distributive property. So I'm going to multiply 5 times x squared, 5 times negative 4x, and 5 times positive 4. So I'm going to end up with 5x squared minus 20x plus 20, and then plus 9. So again, I'm left with one set of like terms, the positive 20 and the positive 9, and I can add those two things together. So I'm going to have 5x squared minus 20x plus 29. Okay, so we've now converted from vertex form all the way down into standard form. So next we'll take a look at factoring, and we've got 2 questions to factor here. The first one, I'll just quickly put a little line over here so that we don't get confused there. So I've got x squared minus 6x plus 16. So I know that I need to have, in my MA chart, I'm looking for 2 numbers that are going to multiply to this c value. So they have to multiply to negative 16. And at the same time, they must also add to negative 6. So we have to multiply those 2 things to the b value. So what we'll end up doing is we're going to look for 2 numbers that multiply to negative 16. So negative 16 and positive 1 will give me that, but it will add to negative 15. Negative 8 and positive 2 will multiply to negative 16, but when I add those two things together, it will actually give me negative 6. So this must be the combination of numbers that I'm looking for. So my factor here is actually going to be x minus 8 times x plus 2. And again, I'm going to continue to factor this. I've got another example here. I've got negative 2x squared plus 128. And we had talked last day about how to factor trinomials when the a value is something other than positive 1. And in this particular example, we see that the a value is actually negative 2. So what we need to do here is we actually need to write this out as a trinomial, because right now it's not written as a trinomial, it's written as a binomial. Remember, trinomials are always written in the form of y equals ax squared plus bx plus c. So in this particular equation, we actually have an a value and we have a c value, but we have no b value. So that means that the b value is actually 0. So I'm going to write this out as a trinomial. So 2x squared plus 0x plus 128. So now I want to get rid of that, that coefficient in front of the x squared. So I'm going to divide everything out by that number, by the a value. And again, the a value is right here. It's that negative 2. So I'm going to divide everything by negative 2. And so again, this negative 2 doesn't just disappear. I have to take it somewhere. So I got negative 2 out front, and then negative 2x squared divided by negative 2 is just going to give me x squared. 0x divided by negative 2 still leaves me with 0x. And positive 128 divided by negative 2 will leave me with negative 64. Now, because my b value is actually 0, that lets me know that the positive form of the c value, which is positive 64, the square root of that is going to be the two factors that I'm looking for. The square root of 64 is both positive 8 and negative 8. And as a result, my final answer is going to be negative 2 x plus 8 times x minus 8. Okay, so in terms of warming up to get ready for looking at finding the zeros, those are some of the skills that we have to have. Being able to factor, being able to expand, and being able to convert from vertex form into standard form.